What if I told you that with a $10 board and a few lines of code, you could control the physical world, turn on lights, read temperatures, build robots, and even connect devices to the cloud? That's exactly what Arduino lets you do. We are from IoT Journal, and in this video, we're going to break down everything you need to know about Arduino from zero to hero in one shot. Let's go. Welcome to this complete Arduino masterclass brought to you by IoT Journal. Arduino is called the heart of DIY electronics for a good reason. It's the tool that bridges the gap between the software world, where we write code, and the physical world, where things actually happen. Whether you're a total beginner who just heard the word microcontroller for the first time or you're already tinkering with sensors and want to go deeper, this video is for you. We're going to cover everything: what Arduino is, how it works, how to program it, how it talks to other devices, and what kind of awesome projects you can build with it. So make sure you stick around to the end, because we have some really interesting stuff coming up. All right, so what is Arduino exactly? Arduino was created back in 2005 by Massimo Banzi and David Quartielles in Italy. They wanted to build something simple, a platform that anyone could use to control electronics, even with zero engineering background. And that's the key word here: open source. Everything about Arduino, the hardware design, the software, is free and open for anyone to use, copy, or modify. That's a huge deal. It means a massive global community grew around it. Inside, Arduino uses something called the Harvard architecture, which means it keeps your program and your data in separate memory spaces. That makes it fast and efficient, even with very limited resources. And the impact? Arduino literally sparked the global maker movement, that worldwide community of engineers, students, artists, and hobbyists who build cool stuff with technology. And today, Arduino is one of the key platforms for IoT prototyping all over the world. Now let's look at what's actually on the board, because understanding the hardware is step one. The most popular model is the Arduino Uno, and it's the one we'll focus on today. First, the brain. The heart of the Uno is a chip called the AT-Mega328P microcontroller. It comes with 32 kilobytes of flash memory, that's where your program lives, and 2 kilobytes of SRAM, which is the working memory while your program runs. Tiny by modern standards, but more than enough for most projects. Next, power. You can power the board in 3 ways: through the USB port, through a dedicated power jack that accepts 7 to 12 volts, or through the VIN pin directly. Now the pins, this is where the magic happens. You have 14 digital I/O pins. These handle binary signals, either on or off, high or low, and 6 of those 14 pins also support something called PWM, which we'll get to in a second. You also have 6 analog input pins. These can read a continuous range of values, not just on/off, which is perfect for sensors like temperature or light. And finally, the extras: a reset button, 2 small LEDs for TX and RX that blink when you're communicating over serial, and the standard power pins. This little board is incredibly packed. Great. So now we know what's on the board, but how does the whole thing actually work? What's the process from your idea to the Arduino doing something in the real world? It's actually 4 simple steps. Let me walk you through them. Step 1. Write. You write your code on your computer using the Arduino IDE. That's the free software you download from arduino.cc. Your code file is called a sketch, and it's saved as a .ino file. Step 2. Compile and upload. When you hit the upload button, 2 things happen. First, the IDE compiles your code. It translates your human-readable C++ into machine instructions the chip can understand. Then a tiny built-in program on the Arduino called the bootloader, only 0.5 kilobytes, pulls your code over USB and stores it in flash memory. Step 3. Execute. The board now runs your code, continuously in a loop, interacting with whatever is connected to it. Step 4. Physical action. This is the fun part. Your code tells the board what to do, blink an LED, spin a motor, read a button, send data to the cloud, and then the loop starts again. This cycle keeps running as long as the Arduino has power. Simple, elegant, and incredibly powerful. Now let's talk about programming. Arduino uses a simplified version of C++, so if you've ever touched C or C++ before, you'll feel right at home. And if you haven't, don't worry. It's designed to be beginner-friendly. Every single Arduino program, every sketch, has exactly two functions, just two. That's it. The first one is void setup. This runs exactly once when the board powers on or resets. You use it to set up your pins, start serial communication, basically get everything ready. The second one is void loop. This runs forever, continuously, over and over, as long as the board has power. This is where all your main logic goes, and the core syntax is straightforward. Every line ends with a semicolon, and you group blocks of code with curly braces. That's really all you need to get started. Two functions, a few rules, and you're writing real embedded code. Now we get into the actual inputs and outputs, and this is where your projects come to life. Let's start with digital I/O. Digital is binary. It's either high or low, on or off, 1 or 0. In terms of voltage, high is 5 volts and low is 0 volts. For digital output, you use a function called digital write. This is how you turn on an LED, trigger a relay, or activate a buzzer. You tell the pin to go high, and the LED turns on. Tell it low, and it turns off. For digital input, you use digital read. This is how you detect a button press, a motion sensor trigger, or any on/off event from the outside world. Now here's something really cool, PWM, or pulse width modulation. Remember how digital pins are only high or low? PWM is a clever trick where the Arduino rapidly switches a pin on and off hundreds of times per second. By changing how long it stays on versus off, it creates the illusion of a variable output, like dimming an LED or controlling a motor speed. It's not really analog, but it behaves like it. Really clever. So digital was black and white, on or off. Now let's talk about analog, which is the full spectrum in between. In the real world, most signals are continuous. Temperature doesn't jump from 0 to 100, it gradually changes. Light levels shift smoothly. A dial on a volume knob sweeps through hundreds of positions. Analog pins can capture all of that. The key component that makes this work is the ADC, the analog to digital converter. It's a built-in circuit inside the Arduino that translates a variable voltage into a number your code can work with. The Arduino Uno has a 10-bit ADC, which means it can represent the full range from 0 to 5 volts as a number between 0 and 1023. So if you're reading a potentiometer, a dial, at exactly the halfway position, you'd get a value of around 512, exactly what you see on this slide. This makes analog pins perfect for temperature sensors, light intensity meters, joysticks, pressure sensors, anything in the real world that doesn't just have two states. You read them with a function called analog read. Super simple. So far, we've talked about the Arduino doing things on its own, but what about when it needs to talk to other devices, sensors, displays, other microcontrollers? That's where communication protocols come in, and Arduino supports 3 of the most important ones. First, UART, Universal Asynchronous Receiver Transmitter. This is serial communication. It uses just 2 wires, TX for transmit and RX for receive. The connections cross, your TX goes to their RX and vice versa. It's great for basic device-to-device communication, and it's also how you communicate with your computer through the Arduino IDE's serial monitor. Second, I2C, Inter-Integrated Circuit. This is a 2-wire bus that uses SDA and SCL lines. What makes it special is that you can connect many devices on the same 2 wires, and each one has a unique address. So one Arduino can talk to a temperature sensor, an LCD display, and a real-time clock, all on the same 2 wires. Super efficient. Third, SPI, Serial Peripheral Interface. This uses 4 wires and is the fastest of the 3. It's perfect for high-speed devices like SD card modules, displays, or wireless modules. Understanding these three protocols is the key to unlocking advanced Arduino projects. Now, the part everyone loves. Let's talk about what you can actually build with Arduino. And honestly, the range is incredible. For smart home projects, you can build automated weather stations and greenhouse controllers using the Arduino MKR Wi-Fi 1010. Imagine your greenhouse automatically watering itself when the soil gets too dry. Arduino can do that. For robotics, people build line-following rovers, obstacle-avoiding robots, and robotic arms. Arduino handles the real-time sensor reading and motor control that makes these work. For edge IoT networks, you can have multiple Arduino nodes sending sensor data to a central server using lightweight protocols like MQTT, perfect for environmental monitoring or industrial sensing. And for cloud dashboards, Arduino has its own IoT cloud platform where you can send your sensor data and visualize it in real time on a web dashboard or mobile app. You can check your temperature sensor from anywhere in the world. These aren't future possibilities. People are building these things right now with tools you can get for under $50. Let's zoom out for a second and look at the bigger picture. Arduino isn't just a hobby tool, it's serious. In education, it's literally the global gold standard for teaching students electronics, STEM, and C++ coding. Universities, high schools, and coding boot camps around the world use Arduino as the entry point into embedded systems. For prototyping, it allows startups and engineers to build low-cost proof-of-concept hardware incredibly fast. You don't need a full production line to test if your idea works. You build it with Arduino first. In industry, the MKR family of Arduino boards takes things to a completely different level. These boards offer enterprise IoT connectivity. We're talking LoRa for long-range low-power networks, NB-IoT for cellular, and GSM for global coverage. And at the advanced end, the Arduino Nanomatter, powered by the MGM240S chip, supports thread and matter protocols, FreeRTOS, and is built for serious industrial applications. So Arduino scales with you, from your first LED blink all the way to industrial-grade connected devices. Let's bring it all together with the key takeaways from this video. Number 1. Bridge the gap. Arduino is the ultimate tool for connecting software with the physical world. If you can write code and you want it to do something real, Arduino is your bridge. Number 2. Pick the right tool. Microcontrollers like Arduino excel at real-time, predictable input-output tasks. They're not trying to replace your computer. They're doing a different job, and they do it incredibly well. Number 3. Master the pins. Once you understand digital I/O, analog I/O, and the three communication protocols, UART, I2C, SPI, you can work with virtually any sensor or module out there. These are the fundamentals that unlock everything. Number 4. Scale up. Start with a simple Uno, blink an LED, read a button. Then, step by step, work your way up. Add sensors, add Wi-Fi, connect to the cloud. Arduino grows with you all the way to industrial IoT networks. Before we wrap up, I want to give you your roadmap for what to do next. First, download the Arduino IDE. Go to arduino.cc and download the free software. It's available for Windows, Mac, and Linux. This is where you'll write all your code. Second, try the built-in examples. Once the IDE is installed, go to File, then Examples. The very first one you should try is called Blink. It makes the built-in LED on the board flash on and off. It's the classic hello world of Arduino, and it takes about 2 minutes. I guarantee you'll feel amazing when it works. Third, explore the Project Hub. At projecthub.arduino.cc, there are thousands of community tutorials for every skill level. You'll find exactly what you want to build with full step-by-step instructions. And fourth, try the Arduino IoT Cloud. Once you're comfortable with the basics, the IoT Cloud lets you create custom web dashboards for your sensor data. It's free to start, and it's genuinely impressive what you can build. And that's a wrap on Arduino Essentials. We covered a lot in this video. From the history and architecture of the board, to programming, digital and analog I/O, communication protocols, real-world projects, and industrial applications. If you made it this far, you now have a solid foundation in one of the most important tools in the Maker and IoT world. I have one question for you, and I really want to know your answer. What is the very first Arduino project you want to build? Drop it in the comments below. Whether it's a weather station, a robot, a smart home gadget, tell me. I read every single comment. If you found this video useful, please hit the subscribe button and ring the notification bell. We do deep dives into IoT, embedded systems, and Maker tech every single week here at IoT Journal. And the links to recommended beginner Arduino kits are in the description below. I've tested them personally and they're perfect for getting started. Up next, we're doing a complete masterclass on the ESP32, which is like Arduino's more powerful Wi-Fi-enabled sibling. You don't want to miss that one. Until then, keep building, keep learning. I'll see you in the next video.